Welcome to the talk of VALO Innovations about innovations in ultrafast fiber lasers, benefit from shorter pulse durations. My name is Oliver Prochnow and I'm the CEO of VALO Innovations. To start, I want to give you a short overview of VALO Innovations. VALO Innovations was founded in April 2018 and is located in Hanover in Germany. Our main motivation is creating new standards in ultrafast fiber laser technologies. And our goal is to provide high-end laser solutions to support our customers. While we are talking about ultra-short fiber lasers, so for us, it's the most attractive light source you can have. So there are some commercial advantages, like they are maintenance-free, they are very easy to use, cost-effective, and they have a high customer value, and finally, a low total cost of ownership. The technical advantages about fiber lasers are very simple. They are turnkey, they offer higher stability, they are very robust and have low noise, and finally, they are scalable in output power. Furthermore, the fiber lasers in general offer a very high bandwidth, so you can get very short pulses. And so what are the applications of very short pulses? So you can benefit from very short pulses like 50 femtoseconds in a lot of fields of applications. Mainly it's multiphoton microscopy, where you can directly see the advantage of multiphoton efficiency. Multiphoton microscopy is used for research on diseases and cancer and Alzheimer. You can use it for optogenetics, which is the research of the brain. Furthermore, you can use ultra-short pulses in nanomaterial processing, like the production of bioresorbable stents and many more applications. So if we're talking about multiphoton microscopy and optogenetics, why are 50 femtoseconds better than longer pulse duration? If we compare, for example, a 40 femtosecond pulse with a 200 femtosecond pulse, you get a 5 times higher efficiency in the two-photon process. If you think about 3-photon processors, you get a 25 times higher efficiency. If you use the same output power, you will get a 5 times reduced thermal heating because you just have a lower average power. And you finally can get a 2 times reduced photo-induced damage. You can get a higher contrast or higher resolution and a deeper scan depth. So what are the VALO Innovations products? The VALO Innovations offer two systems. The first one is an Alto system, which typically delivers 40 femtoseconds in pulse duration. The average power is 200 milliwatts, which corresponds to 6.5 nanojoule. A higher power version is the VALO Innovations Tidal. It offers 50 femtoseconds at a 3-watt output power, which corresponds to 100 nanojoules. At the moment, we are working on a high-energy laser system with 50 femtoseconds and 1 microjoule of output power. Furthermore, we offer also customer-specific solutions in the range from milliwatt to up to 50 watts or nanojoules to 100 of microjoules. So what are the features? The features are the system is turnkey, passively air-cooled, it's remote controllable, and the system offers an integrated dispersion pre-compensation module. And you can see here the size of the system. If we talk about the specifications, typically the lasers are built with a 30 megahertz repetition rate. The pulse duration is below 50 femtoseconds, which you can see here. It typically results of 35 femtoseconds. The output power is 200 milliwatts. What you can see here is the optical spectrum, which corresponds to the pulse duration. And finally, we have a peak power of 160 kilowatts and a pulse energy of roughly 7 nanojoules, and a very good M-square of below 1.2. If we're talking about the performance, you can see here a measurement of the output power about 24 hours, which offers a stability of 0.03%. We have a nearly perfect Gaussian beam profile, and we did some self-starting tests, which you can see here. So the laser starting. For the high power versions, the Tidal, it's also built at 30 megahertz, and the pulse duration is typically 40 femtoseconds or below 40 femtoseconds. And you can see here a result of 29 femtoseconds of pulse duration. The output power is around 3 watts, and the peak power is 2.5 megawatts. Finally, it corresponds to a pulse energy of 100 nanojoules. I just want to talk about the recent developments. The recent developments are scaling the average power, which enables a multiphoton multi-line approach. So finally, we want to get something like 1 microjoule at pulse durations below 50 femtoseconds. Main applications here are 2 and 3 photon microscopy, optogenetics, and micro and nanomaterial processing. Another option is to generate different wavelengths. So it should be an option to tune the laser wavelengths or to have multi-output outputs in parallel. So we think about wavelengths at 800 nanometer, 920 nanometer, 11 or even 1200 nanometers. And at these wavelengths, you can also get a very short pulse duration of below 50 femtoseconds. And these are also the application of 2 and 3 photon microscopy, spectroscopy, and also optogenetics. You can see here on the side the optical spectrum from 700 up to 1400 nanometers, or just the filtered version, which corresponds to a sapphire laser. So if we come to an end, we just have the typical epic questions. So what can you do for us and what can we do for you? So we can offer pulse durations from 30 femtoseconds and up to 30 watts. We can offer non-standard wavelengths like 550 nanometers, 1110, 1200 nanometers, and we can also offer customized solutions. What can you do for us? So if you have any kind of application ideas, it's interesting to talk about it. If you have some challenging parameters which you cannot get on the market, we can also discuss it. And we are interested in collaboration and help you too. Thanks for your attention. And if you need further information, please contact us at info@valo-innovations.com.